Well, good day, everyone. Welcome to session 6 of the GEO Virtual Symposium. My name is Doug Kripe. I'm one of the co-chairs of the GEOSS Infrastructure Development Task Team, and this session is devoted to understanding what the GEOSS Infrastructure Development Task Team has been up to, what their thoughts are on planning the next infrastructure for GEOSS. Just to tell you briefly about the Infrastructure Development Task Team, the team works to underpin GEO's mission to provide sustainable Earth observation data to support decision making. So in this session, the GIDTT, as we like to call the GEOSS Infrastructure Development Task Team, the GIDTT will provide a comprehensive look at various components of the GEOSS infrastructure, and also the evolution that is foreseen as outlined in the work program. We'd like to invite you to this session, along with my fellow co-chairs, Ivan Deloach and Stefano Nativi, to provide some insights to you on our plans to support GEO. We'd like to engage you in the conversation after these presentations to help us understand how we can best support your needs for activities of the work plan across the flagships, regional initiatives, and other activities. Real briefly, in this session, we are going to hear 4 presentations. The first presentation, again, will be given by my fellow co-chairs, Ivan Deloach and Stefano Nativi. They will be introducing the GEOSS Infrastructure Development Foundational Task. Then Stefano will give us a presentation on how GEOSS is seen to evolve, a step-by-step approach. Then Paolo Mazzetti and Joost van Bemmelen are going to take us through a presentation on the evolution of the GEOSS platform. And then finally, we'll hear from Natalia Donahoe on GEONETCast on their plans for the future evolution of GEONETCast. At that point, we will open up the floor for questions and answers through Slido. And without any further ado, I would like to turn it over now to Ivan Deloach and Stefano Nativi to give us their presentation on the GIDTT.
Thank you, Doug. It's definitely a pleasure to participate in this particular session on the GEOSS Infrastructure Development Task Team. On behalf of my co-presenter, Stefano Nativi, we welcome you to this session. My name is Ivan Deloach, and I serve as the Executive Director of the Federal Geographic Data Committee in the United States, and serve as one of the co-chairs of the GEOSS Infrastructure Development Task Team, as well as a member of the GEO Program Board. I've been involved in developing of spatial data infrastructures and working with GEO for a number of years since its inception.
Yeah, thank you, Ivan. I'm Stefano Nativi. I work with the European Commission, the Joint Research Center. I'm a big data lead scientist, and I'm one of the co-chair of the GIDTT, and I've been engaged in GEOS for many years.
So today, Stefano would just like to take an opportunity to share with you and introduce some of the information and topics behind the work that we're doing with the GEOSS Development Task Team. It's one of those significant foundational tasks that's included in the 2020 and 2022 work program. Some of the key activities that the GEOSS Infrastructure Development Task Team leads are a development and implementation of the common infrastructure elements that are identified in the work program. But the task team also provides the infrastructure to facilitate interoperability between the GEO flagships, the initiatives, and community activities. In addition, one of the more important aspects and responsibility of the team is to address the user needs and significant gaps in data and services. And more importantly, one of the key cornerstones of GEO for a number of years has been the realization of the GEOSS data sharing and data management principles, which the GEOSS task team shepherds throughout its processes. Over the past several years, there have been a number of activities that we've conducted and been involved in that's really served as the underpinning for the work of the task team. There have been a number of data provider workshops that have been executed over the years. We've also taken steps to improve data management and the use of interoperability standards. One of the other key activities that we've been involved in is supporting the GEOSS platform, the pilots and use cases that have been instrumental in providing the underpinnings of moving us towards a user-driven GEOSS. As we think about the way forward, there are a number of activities that establish the new GEOSS platform and its integrated components. We've had the GEOSS portal that's been developed and supported by our colleagues at ESA. In addition, we've had the data access broker that's also provided a means of finding and accessing data. And also, there are a number of new services and features of the portal that we're also utilizing as part of the new infrastructure. Just to talk a little bit about how we're organized, there are 5 key components or work groups of teams that have been identified and articulated as part of the 2020 and 22 work program. The first team is the GEOSS Infrastructure Development Team, which oversees a number of the activities and components for foundational tasks, as well within the foundational tasks that ensures connectivity and synergy. The second important team is the GEOSS Operations Team, Platform Operations Team, which has the responsibility for the daily operations of a number of the services provided through the GEOSS platform. And this includes the GEOSS portal, the GEO data access broker, the status checker, which is very important in monitoring the progress of GEOSS, and also the GEO Yellow Pages, which serves as that data catalog and has that documentation that's important for the users in identifying and accessing data. Third group is the GEOSS Infrastructure Evolution Working Group, which has the responsibility for the evolution of the infrastructure and the architectural components associated with that. And you'll hear more about this in Stefano's presentation shortly. And it includes members from the former GEOSS Evolve Working Group that has always had his eye on the future in terms of where the technology is taking us. The fourth key team or group is the GEONET operations team, which has been in place for a number of years and one of those cornerstones of GEO. And it provides a lot of those services and satellite information to a lot of the developing countries. And then lastly, but not least, is the new component, the GEO Knowledge Hub and Open Source team, which is led by our colleagues in the Secretariat and has the responsibility for the development of the proof of concept of the Knowledge Hub, and then also has the responsibility for the coordination of efforts on open source solutions. Some of the expected outcomes from the work that we're doing are to expand the access and reuse of Earth observations. We also are looking to improve the discovery and access to data and information and make those resources available from our GEOSS data providers. We're also taking steps to address the user needs and gaps. As we know, this is a user-driven GEOSS, and it's very important to understand those needs and those gaps. We're taking steps to expand the number of providers and users, and we've been doing this, as I stated earlier, from a number of the workshops that we've been conducting in the past several years, and those have been very successful. We're evolving the GEOSS architecture to support the analyses and decision-ready analyses that are important to our users. This would also include the considerations for how we utilize data cubes and other hubs that are available to us. We also want to improve the GEOSS services to meet user needs and adopt new standards and methods where applicable for the technologies that are evolving on a daily basis. And then lastly, we're piloting the GEO Knowledge Hub concept for product generation and reproducible knowledge. And with that, I'll now turn it over to my colleague Stefano DeFibi.
Thank you very much, Ivan. And I'm just going very quickly to cover a few of the concepts introduced by Ivan. The GEOSS platform, indeed, one of the components is to continue operating the GEOSS platform as one of the key instruments in order to connect the resource providers and the GEOSS community, in particular the potential users here. And here we are talking of something like 10,000 organizations sharing directly or indirectly their resources, not only data, and about 15,000 organizations which are unique users of the GEOSS platform. And in particular, in this area, we have organized workshop called Geo Data Provider Workshops, where we invite them and we listen to them, collecting their inputs and feedbacks in order to advance the services and the functionalities of the GEOSS platform. And this is exactly what we have been doing in the past years, because these inputs and these feedbacks provided valuable developments in GEOSS platform, allowing the GEOSS platform team to develop new services, provide also support in order to enrich the user experience, but also make the life easier for the data provider, the data and information provider, when they want to be engaged, be connected, and share their resources. And another, of course, important component here is about the evolution of GEOSS architecture, and this is going to be a major step, and this will be the final result of a stepwise approach, starting exactly from these needs, and objectives and business objectives coming from the resource providers and users, and passing through scenarios. And then as far as the technological side, indeed we are living in a completely different technological era, where big data, machine learning, digital twins, are getting more and more present, and so we need to advance the present GEOSS architecture in order to include all these capacity and all these tools. And here just a couple of schemas to show how we are, working in order to understand at the conceptual level the best patterns in order to connect, but also to keep with the GEO principles, which are architecture principles as well as, data sharing and management principles. And another important point in terms of action and expected outcomes here is to engage more and further with regional GEO, because regional GEO play a fundamental role in order to connect to decision makers, but also the local and the national level. So in order to stay in touch with the resource producers, but also as well as users. So this is definitely an important goal. The other one is to establish further interoperability with the other global initiatives which are interested in the same strategic area of GEO, in particular Sustainable Development Goals, disaster risk reduction, and climate change. And that's it. Thank you for your attention.
Okay, thank you very much, Ivan and Stefano, for that overview of the work that's happening within the GIDTT. Again, GIDTT, it's a little bit of an unwieldy acronym. Several people have asked, how do we pronounce it? And I don't think there is universally accepted guidelines on that just yet. So if anyone has a good idea, please let us know. Anyway, now we're going to delve a little deeper into GEOSS itself. And just as a reminder, for those of you who may not be totally aware of what GEOSS is. GEOSS stands for the Global Earth Observation System of Systems, and this is one of the ways in which, or the main way in which GEO is attempting to deliver Earth observation themselves, the Earth observations themselves, as well as information associated with that for use by the global community. And so Stefano Nativi has been very intimately involved in the development of GEOSS, and he's going to take us through some thoughts on how GEOSS is going to evolve in the foreseeable future. So thank you, Stefano, for your presentation.
Thank you, Mr. Chair. I'm Stefano Nativi. I work for the European Commission Joint Research Center. I'm presenting on behalf of all the members of the evolving GEOSS component. In particular, I'm going to tell you what is going on in this group, and in particular how we think to develop our work in a stepwise way. Actually a couple of years ago, we produced as GEOSS Evolve initiative a white paper which is called Challenges to be Addressed in Evolving the Global Earth Observation System of Systems. And this is actually a starting point of this activity, and I'm going through the main outcome of this report, and I'm telling you what is our vision in terms of present and future work. And here we recognize three main areas where there are challenges. The first one is the governance, the second one is the architecture, and the third one is the interoperability. Before getting down to these areas, let me say that in these couple of years, of course, there have been some developments which are pretty important in order to understand how to advance GEOSS. And so let me start with the first development, which is about the regional node of the GEO, and I'm talking of the regional GEO initiatives, AmeriGeo, AfriGeo, Asia, and Oceania Geo, and Euro Geo. This is a quite important, development because they are fantastic instruments in order to reach out to a policymaker further and to understand which are the regional and national needs, but also which are the possible users at that level. And the other development here, it is the constant improvement of GCI in terms of instrument to engage resource providers as well as users. And today we are counting about 10,000 organizations sharing directly or indirectly their resources through GEOSS, and about 15,000 users. 15,000 unique user organizations. And the third development, of course, was the introduction of the GeoKnowledge Hub concept and services. So now it is clear that the GEOSS has to embrace more and more the concept of knowledge sharing and not just data and information sharing. And another important consideration to be done, it is that still GEO is pretty much to stay with its principles, because this is the main reason, to have a GEO and a GEOS. And here I just collected four main set of principles. First one are governance principles, such as, GEO is a voluntary, non-binding participation initiative, consensus-oriented decision-making is applied, transparent management, inclusiveness, multilateralism, etc. Then there are three sets of more technical principles, in particular data sharing and management principles and architecture principles. And I don't go through all these points because I'm sure that at least for the data sharing and management, you know them very well. As far as architecture, these must be open, effective, flexible, sustainable, and reliable. So now it is time to talk about the challenges. Let me start from the governance challenges. And we recognize an important need, the need to introduce this new regional GEO node level. This is particularly important, as I said, and the assumption, of course, it is that all of these initiatives and nodes are implementing the GEO principles that I mentioned before. So the challenges are, what is the governance required in order to connect this level with the existing level, such as, the GEOSS platform, but also, the other components such as the flagships, the community, of the GEO. So the governance, of course, must be updated and must be advanced in order to include this level. Then other challenges are more architectural oriented, such as, how these nodes are positively contributing, to enhance the GEOSS platform in terms of discoverability, accessibility, and knowledge generation. And here we are considering three main different governance scenarios. The first one is called the collaborative model. It is a model where all the different components and levels share resources, but with a pretty good central control. While in the knowledge model, the second one, this control is definitely relaxed, and so we are going towards a more federated or virtual network approach. And finally, there is the autonomous model where all the components are developing their own business, and only when needed, and sometimes they may or not collaborate. Well, according to us, it is worthy to focus on the first two models because the third one doesn't seem to apply all the GEO principles that I presented before. So now I'm going to discuss the architecture challenges. So let's say that we are going to implement one of the two styles, or more likely a sort of hybrid, solution. And of course, assuming that we are still, applying the architecture and data sharing and management principles. So what are the challenges here? The challenge here is to evolve from a multifunctional system, so a platform which is doing several different functions, into a web-based ecosystem where there are different components working together by utilizing the web as the platform, okay? And in this case, we are also able to leverage more and better the new ICT capacities and tools such as the big data analytics platform, the digital twin systems, etc. So in this case, we drafted a couple of possible architectures. The first one, which implements the collaborative governance model with a tightly interoperability style. What does it mean, tightly interoperability style? That basically means that each layer, each functional layer has to talk only with their neighbors, and they cannot skip, these neighborhood layers. While in the loosely coupled approach, this is not true. So, layers can just talk with any other layer. And in this case, in the collaborative model with a tightly interoperable style, as you can see, there is a central node which is communicating with all the other nodes, the regional nodes in particular, but there is only one entry point for GEOS, and it is at the global node level. While in the knowledge model, in particular applying a loosely coupled approach, we have several entry points, and all the components, all the nodes can communicate each other. Clearly, another challenge to be faced in refining these models, it is how to move from the present interoperability level, where we share mainly data, so we discover and we access data, to a more sophisticated interoperability level, where we share concepts of a semantic interoperability, but also where we orchestrate different components and services, so what is called a pragmatic interoperability. Well, in this case, of course, we need to work together with the regional GEO nodes, but also with the third-party platforms in order to understand, which kind of instrument and which level of interoperability they use and they allow. And this is where we are today. This is a standing, schema. So it is a work, design, and here you can recognize the GEO ecosystem, and in particular the three main components here, which are the GEO flagship community portals and other applications, the GEO platform, and the regional GEO infrastructure or systems. Then we have the external environment, so the big data analytic system and infrastructure, and the other international system of systems. And then we have the resource providers, data, information, and knowledge, which share their resources at different levels. So could be national, could be regional, or could be even local. And okay, this is the same concept, just to show you better which are the main components. And here, just to tell you what are in our radar these big data analytics systems, for instance, Africa and Australian data cubes, the Copernicus GEOSS Platform, the Google Earth Engine, the Amazon services, etc. On the other side, when we think of these thematic and international federated systems, we are thinking of WMO, WIGOS, or UNEP Live, UNGPDD, or GGIM, CEOS, the space agency, thematic platforms, the networks, the global networks such as GPIF, etc. I already covered this slide. We distinguish between the collaborative model and the knowledge model. The first one is more centralized, the second one is more federated, and in this case we are applying the tight interoperability style. So each layer is communicating only with its neighborhood. And while if we relax this communication style, so we implement a loose style, as you can see, it is possible to skip layers, and so to have layers that communicate with other layers, even if they are not neighbor. And this is what we are considering presently, but this is an ongoing work, so there is time also to change this schema, evolving it according to the needs and the inputs. But today, as I said, we are considering something that can be considered in between a collaborative model with a loose coupling interoperability style and a knowledge model with a tight style. Okay, and finally, I present you a couple of recommendations in order to move on and advance with the development of the future GEOS. GEO must leverage the new architectural patterns and the technological developments in order to extend and increase the level of services of the GEOS to its community. As I said, the community consists of more than 10,000 data providers and about 15,000 unique user organizations. Then to maintain a GEOS as a system of systems, that's particularly important in order to have such ecosystem philosophy based on interoperability, so establishing interoperability among the different systems and components in order not just to share data but also knowledge, as we outline. And in order to do that, we need to govern this change, and I already presented what are some governance challenges here. And to reinforce the process of formalizing, sharing, and making reusable the knowledge existing in the GEO community. So it must build on the community and not, redoing what the community has been doing. To ensure interoperability with the new the ICT instruments, in particular, for big data management, analytics, and insight generation, and reinforce interoperability as well with the other international and global initiatives in the same strategic area of GEO, such as the Sustainable Development Goals, the disaster risk reduction, and the climate change. And that's it. Thank you for your attention.
Okay, thank you very much, Stefano, for sharing your thoughts with us on how GEOS can evolve into the future. If those of you who are watching, you'll remember one of the slides that Stefano showed depicted the conceptual architecture of GEOS, and at the center of that was the GEOSS Platform. So our next presentation that's going to be given is by Paolo Massetti and Joost van Bemmelen on the GEOSS Platform itself. The platform, the GEOSS Platform is what actually drives the system of systems of GEOS. I like to think of it as kind of the carburetor and the crankcase of the engine that drives GEOS. So we're going to take a little deeper dive even yet into the nuts and bolts of the GEOSS platform with this next presentation.
Good morning. I'm Paolo Mazzetti from the National Research Council of Italy, and I'm going to present the GEOSS platform and its potential contribution to the next GEOSS evolution. I'm presenting also on behalf of Joost van Bemmelen of ISA and all the participants in the GEOSS platform operation teams and working groups. In my presentation, I will provide a short introduction of the current status of the platform and propose some points of discussion about the potential contribution to the next GEOSS evolution. The GEOSS platform is the central component of the current realization of GEOSS, whose vision was described at the very beginning of GEO activities in 2005 as a system to support decision with timely Earth observation data and information. This vision identified the two main actors as the existing systems as resource providers and decision makers as resource end users. However, connecting them is a hard challenge due to the large gap between them. For decision makers, it's not easy to discover, access, process, and use the right data for decision among the many offerings. So the GEOSS platform aims at bridging this gap between providers and users, including not just end users, but also intermediate users, as for example scientists or software developers, who typically provide the knowledge and tools for basing decision on Earth observation. And in doing this, it applies the so-called separation of concern pattern, which suggests to let the actors focus on their fields of expertise. For example, in this case, resource providers can focus on upstream services to publish quality data, while intermediate users can focus on downstream services, generating and visualizing the knowledge required by its decision makers. And in this picture, the GEOSS platform covers what is also called the midstream services layer, where actually made of those value-added services, including interoperability, harmonization, integration, that are necessary to facilitate the access to heterogeneous systems for different applications. But this central component can be actually realized according to different approaches, architectures, and technologies. There is only a governance constraint that actually this central component should implement a system of systems in order to let existing systems functioning and evolving according to their own mandates and governance arrangements. And this explains why the GEOSS infrastructure underwent many changes during the last 15 years to adapt to policy and technology landscape changes. So if we look at the GEOSS infrastructure history, we can identify some major milestones for this evolution. With the first one, of course, as the establishment of the Group on Earth Observation, with the mandate of building the GEOSS. Around 2008, the first GEOSS common infrastructure was released as a clearinghouse catalog that is a metadata repository including information about the protocols supported to connect with the different provider systems, selected from a set of specification approved or under approval in GEOSS. And around 2010, a first GEOSS portal was released to query the clearinghouse catalog. In 2012, the Discovery and Access Broker was deployed as a new component of the GCI. It is a mediator directly connecting with existing systems. And this was actually a major change by a governance and architectural point of view, because adopting a mediation approach to complement the adoption of standards, GEO basically lowered the entry barrier to providers, since now most of the burden and effort to interoperability was moved from the providers to the GEO support and working groups. This actually required also to revise the portal, and a completely new, redesigned and developed GEOSS portal was released by ISA at the end of 2015. Finally, new components like GEOSS mirrors, GEOSS widgets, and application programming interfaces opened the GEOSS infrastructure capabilities to machine-to-machine interaction and to developers, making it a GEOSS platform. So basically, the GEOSS platform main components are the GEOSS portal, which is the general purpose user interface to GEOSS, and it is developed as a framework including reusable portal components, so-called GEOSS widgets, and also the capability to generate mirrors that are replicas of the portal for creating and tailored community portals. The Discovery Access Broker is the mediator, providing uniform access to heterogeneous resources. It also exposes application programming interface for machine-to-machine interaction, and it also implements GEOSS views that are the possibility to expose selected subsets of GEOSS resources for specific communities. The GeoStatus Checker is a component that monitors the status of remote data sources for checking availability, and is important in a distributed system. And the GEOSS Yellow Pages, which support the geo-provider registration process. So to summarize some information about the operational GEOSS platform, we can say that it is nothing less and nothing more than an advanced data discovery and access system. Nothing less because actually it connects now almost 200 open data catalogs and information systems. What is interesting is that most of these sources provide also non-satellite datasets or mixed datasets, including both satellite and non-satellite. It actually gives access to something like 45 million dataset metadata fields with over 400 million granules. Of course, the granularity depends on the data source, so it is difficult to give a clear definition of datasets and granules, but the order of magnitude is the one showed in the slide. It supports more than 35 protocols and protocol profiles. It makes dataset accessible when made available by the providers. It provides advanced functionalities like views, bulk download, which is the possibility to download a set of data, and data transformations. It supports interaction with humans through GeoPortal or dedicated applications, and machines through application programming interface. It provides a configurable query result ranking. It collects usage statistics at portal and broker level, and it is deployed on an elastic cloud for high performances and high availability. But of course, there are some limitations. This is the reason why I say it is nothing more than a data discovery and access system. First of all, it currently supports only discovery and access of data. And we know that there are other important resources that are currently not supported, like documents, code, and so on. It has a limited semantic support. For example, discovery is based on keywords and also only on textual content of selected metadata fields like abstract title. Ranking is configurable but based only on the metadata content. There is no link between resources, and basically it implements a discovery, download, processing, publishing pattern, which is not the best for big datasets, for example, for many satellite datasets. So what's next? What's the future? Of course, we can imagine a sustained operation and incremental innovation, which means brokering new sources, provide enhancements based on community requests. This is what it was done recently, for example, in the last 2 years, mostly through the European Commission Edge project support. 55 data sources were connected, with other 24 data sources updated. New functionalities were implemented on request of communities, like two-step queries, bulk download, the support of dedicated search fields like magnitude for earthquakes, sensor types, and so on. And the statistics collection was improved. And we can also imagine a radical innovation, and this should be done integrating solutions proposed and experimented by the Evolution Working Group. But what actually the GEOSS platform operation can also provide in terms of future development is a set of lessons learned, basically. One, for example, is the link with user communities, because while radical innovation can be suggested by changes in the policy and technological landscape, incremental innovation can greatly benefit from the user community feedback. And this is what happened during the work of the GEOSS platform operation. Another point is the mediation pattern, because GEO is a multidisciplinary initiative, and we know that different communities have their own standard and profiles for sharing resources. And GEOSS is what is called an acknowledged system of system, not a directed system of system, meaning that GEO cannot impose anything to providers. And providers would like generally sharing resources through GEOSS, but often cannot dedicate effort to that for financial, legal, or technical barriers. So mediation basically means that the GEO community put the most of the effort to connect with the providers. Another point is addressing intermediate users like developers and scientists who are typically proxies to the decision makers. We did this providing several ways to interact with the platform. For example, through standard service interfaces for system integration or direct connection with standard-based tools. We provide custom APIs for web mashup supporting rapid and agile development, and also software libraries for developers who are not expert in geospatial technologies. Another important lesson learned is to consider that being a central component means that we can provide value-added.
Well, it looks as though, or it sounds as though we have lost the audio to the presentation. So I think that we had reached the end of it with the conclusions here. Maybe the final point here is a good one to think about, that the GEOSS platform team is interested in collaborating with regional GEOS, GEOs, the full GIDTT and others to develop a platform that is of highest use to everyone out there. All right, I guess that will conclude. So thank you very much, Paolo Mazzetti, for taking us through your thoughts on the various components of the GEOSS platform and the infrastructure. We have one more presentation in this session. We're going to shift gears a little bit and hear about GEONETCast. And again, for those of you who are not familiar with GEONETCast, it is a facility that has been available nearly from the beginning of GEO back in 2005. That is a collaboration between various space agencies that permits people to download directly Earth observation information. And this is particularly useful in areas where internet infrastructure does not exist or is insufficient. So this has been particularly successful across Latin America, Africa, and Asia. And with us is Natalia Donahoe, who's going to tell us give us her thoughts on GEONETCast and its background and looking forward to how it's going to evolve.
So I'm really happy here today virtually, and I'm delighted to have all of you joining us today in the cyberspace. Before I begin, I would like to thank my colleagues at EUMETSAT and China Meteorological Administration, who are my collaborators for this talk. I can skip my bio, you can read it later. And so what is GEONETCast and why are we talking about GEONETCast here? So in my presentation, I provide some background, update, and activities and highlight our plans. So GEONETCast is an information delivery system, and it's a global network. It's based on various broadcasting systems, and it works like satellite TV. So, and also we facilitate access to data to support the geosocietal benefits areas. GEONETCast is based on collaboration between China, EUMETSAT, and the United States, and that's where I work. I work at NOAA. And so architecture is open and it can accommodate other partners. We work really closely with EUMETSAT and CMA. As I mentioned earlier, it's based on various regional broadcasting systems or commercial TV satellites, and using multicast, access control, broadband capacity, basically C-band or Q-band, if you're familiar with technical options. We currently have more than 7,000 users in over 169 countries. So, as I mentioned earlier, collaborated with CMA and EUMETSAT. So there's 3 different components to that. GEONETCast America is Western Hemisphere, and it's operated by NOAA. EUMETCast is EUMETSAT contribution, and CMA-cast is China's contribution to global GEONETCast. GEONETCast supporting GEO, and we support GEO objectives. GEONETCast is also used as data transmission where high-speed landlines or internet are not available, and that's important, especially now during the pandemic situation. Sometimes internet is overloaded and you don't have good connection, or you don't have big antennas, so you can actually get data using small antenna, sometimes portable satellite antennas, and you can get data over GEONETCast. GEONETCast provides a lot of products and services, and we're actually able to disseminate high volume of data worldwide. And by the way, any format can be transmitted. GEONETCast also delivers a wide range of satellite data and products generated by CMA, EUMETSAT, or NOAA, or actually we have some third-party providers as well. This is just a quick sample of products, and we have variety from forecasting tools and data and services to such as like atmospheric aerosols or sea surface temperature, imagery, and variety of products. And of course, we're really serious about capacity building, and capacity building is one of the GEONETCast achievements. Not only we have training workshops, but we also have a training channel. We can disseminate several materials, and especially where internet connectivity is limited. We have, it's open to all GEONETCast data providers and users. So we also have disaster channel, and it's available to deliver products in support of international charter and space and major disasters. It's like I said, we do provide training workshops in the regions, and of course, a lot of them have been virtual lately. And for the long-term goals, we really looking to engage with stakeholders to address global and regional challenges. We are fostering regional cooperation and looking forward to develop more cooperation with academic institutions. We're looking for regional providers to share data and information. And also we want to strengthen the relationship between GEO and member countries through building and reinforcements of regional GEO networks. And of course, this is just a contact page for CMA-cast, EUMETCast, and GEONETCast America. Feel free to contact us at any time. We have web pages and social media accounts available, so we'll be happy to hear from anybody who has questions. For your time, and looking forward to discussing if you have any questions. So, thank you very much.
Okay, thank you very much, Natalia, for that presentation on GEONETCast. At this point, we've concluded our presentations, and we will now take your questions as they're appearing in Slido. So if I could ask my co-presenters to switch on their video, their webcams, so that people can see us. We'll go into the section of this session where we handle questions and answers. So, for the first question here, I'd like to ask, I'll just throw this one out to anybody who would like to answer. The question is, how are you interacting with users? Do you have a systematic way of engaging with the very many different types? Think of user profiles of users of GEOSS. So I'll throw that question out to any of my colleagues here.
Thanks, Doug. I'll take the first crack at that one. I think over the past number of years, we've recognized the importance of engaging with users, and I think we've taken a number of different approaches. First and foremost, we've utilized a number of workshops that we've supported over the years to engage not only users but providers in bringing those communities together to better understand their needs. Second of all, I think we've used the GEO Symposiums, as we're doing today, to identify those communities by which we can engage. And then lastly, a couple of years ago, we recognized the importance of reaching those users at a regional level. So we started to organize a number of the regional nodes to allow us to more systematically engage with users who have some very similar needs and also interests at the regional level. I still think that we need to be a little more creative in how we do that, a little bit more systematic in how we engage those users. And hopefully, as we continue to evolve the GEOSS infrastructure, we'll continue to do more of that.
Stefano,
to this. Stephanie, you want to go first, please?
oh, thank you. Thank you, Joe. Sorry. I mean, yeah, no, I definitely, echo Ivan about the importance of the GEOSS data providers. But when we say data providers, we must say that we also invited users, and users were, attending. This is, this has been a real important instrument, and so we have planned to, go on, of course. And let me also add that another important instrument was to collect statistics and feedbacks through the GEOSS platform, but I'm sure that maybe just wanted to intervene on this point. So let me also stress another important way about this, and it is to engage with user needs coming from the new developments that we have seen recently in the digital transformation. As also Paolo said, we have seen that there are a clear shift of patterns here from the discovery, access, and use. Now we have a different patterns where, of course, platforms are playing a major and important roles. And this was also studied when through GEO we engage with the flagship. We used to have regular meetings with the GEO flagship and the GEO data providers in order to listen to their needs and their experiences. So I think that these are all good instruments, and we should try to revamp or strengthen in some cases. Please, Jost, and sorry if we clashed.
It's always a pleasure, let's say, to work together with all of you. Anyway, on top of what was mentioned by my colleagues, I think it's also good to refer to what Ivan already mentioned. We have these GEO let's say, data provider workshops as well, where we had them meet users as well. So there as well, we came into contact, let's say, with the different users. We also as well organized online workshops, community-related workshops to better understand, let's say, their requirements and to agree on scenarios, actually. Actually, at the end, let's say we had over 2 years activity, which was co-financed by the European Commission via a project called EDGE. We had some 40 scenarios implemented, having contacted quite a wide diversity of users to evolve actually the GEOSS platform. So I think there's quite some activities that we have been undertaking in getting contact with the different user communities from a quite wide variety of thematic application areas. Thank you.
Okay, thanks. I think maybe we'll move on to the next question. We've got quite a few here to try to get through in the time that remains. Kind of related to this question is one here that asks, are there any examples of case studies or use cases for the GEOSS platform? It's mentioned that there are many users. So what would be some examples of how the GEOSS platform has been put to use? Again, I'll just throw that one out to anybody who would like to respond.
Okay, so let me start, this time. I'm sure that my colleagues will jump in and add other valuable use cases. Well, I mean, when we look at the users and in particular their request in the last years, we discover a couple of quite interesting, use cases. One was the WMO. We saw that in a particular WIGOS, were using, GEOSS in order to collect, harvest, of course, non-meteorological and climate data, the other kinds of data on one side, and on the other side to publish their data using, GEOSS as one of the instruments, because clearly GEOSS was not, it is not the only instrument. So this is, a typical example of how we can engage, in this case, with big organizations and international organizations. Another, big one was China. I mean, they have been developing their very, effective GeoChina infrastructure, and so they were connected, and they are connected through the platform in order to, exchange data, but not only data, information, as well. These are a couple, a couple of stories clearly, in this case, concerning big infrastructure and organizations.
Okay, thank you very much, Stefano. Here's a question for Natalia. During the presentation on GEONETCast, it was mentioned that there has been engagement with academia, national and global communities. How about private enterprises and civil society? What kinds of engagement has there been, if any, on that side?
Oh, thank you so much for that question. So we tried to reply online already. Certainly on NOAA side and GEONETCast side, we have commercial users. So and I know they're part of user groups. So we try to engage with them. We don't have commercial companies as providers, but we have obviously NOAA is the United States government organization, so we provide NOAA satellite observations and data from the government side. But we have commercial users, but we don't have them as providers on NOAA side. And I think it's the same with GEONETCast. I'm not sure about CMA.
Okay, great. Thank you
Thank
very
you.
much. Yeah. Let's see. I have a question here. I think this one would be directed to Stefano. Considering the current lively dynamics of the technology surrounding data cubes, artificial intelligence, machine learning, and so forth, wouldn't the centralized, tightly coupled model that you presented for GEOSS, wouldn't that approach perhaps present a risk to miss opportunities in this kind of fast evolving situation?
Yeah, okay, thank you. Yeah, indeed, I mean, I share about the, inception here. Indeed, I mean, we are living in a fast evolving technology landscape. Well, as far as the presented a possible architectural solution, this is not, centralized. This is what I try to, explain. We are moving from a pretty centralized schema into something which is more distributed, but still we are discussing about keeping a centralized entry point. Why? Well, because clearly, I mean, as it was said several times, this is a system of systems. So basically it means that you have to govern this, super system, because system of system is a super system. Then the real question is what this governance should do. And as Paolo said, I mean, certainly it is not, it is not supposed to control all the different contributing systems. It is not supposed to fund directly them, but to leverage the autonomous, fundings, etc. So, but still, we need, according to at least the GEOS, design, or the GEO, principle, we need one common level. And this common level, it is what may be considered as a centralized component. And so now we have to decide what are the functionalities of these, central components. But apart from this, all the other, architectural scheme, it is pretty, distributed.
Joost or Paolo, do you want to add anything to that?
No, I basically agree with Stefano. I wouldn't say that the GEOSS platform is or will be, according to the evolution presented by Ivan and Stefano, is a centralized infrastructure. It is a system. It is conceived as a system of systems, which means actually to try to connect, to coordinate the contribution in a distributed system.
Okay, great. Thank you very much. Let's move on to the next question here. I think maybe I'll direct this one to Ivan. And it's concerning citizen science. So to advance researcher and public participation in using Earth observations, are you considering how citizen science can be integrated into the architecture of GEOSS?
Well, thanks for the question, and absolutely. I think over the past several years, we've seen the value, the utility of citizen science. The question is ensuring that we qualify that information as we incorporate it into the system. We're seeing that as a great example right now as we deal with COVID-19 and how important the value of citizen science and understanding where the virus is and how it's impacting our community. So I think we have to take a very hard look on how we do that in a systematic way, but absolutely we are considering the use of citizen science.
Great, thanks. Another question for Natalia. How does GEONETCast interact with the academic community, and in particular with research and education networks such as GEONT, ASREN, Clara, and so forth?
I was trying to reply online. So looks like from EUMETSAT side, I have a cooperation with GEON. So through EUMETSAT Terrestrial and with the multicast system on NRAM with several users in various continents. On NOAA side, on GEONETCast America side, we have several users in academia. However, I don't have specific partnerships. So I'm going to look into this. This is a really good note. And we have NOAA Cooperative Institute as providers on GEONETCast America. So just remember that my user base is significantly lower than EUMETSAT's and CMA. I only have about 90 users in 20 countries. On EUMETSAT and CMA side, I have thousands of users in Africa and Asia. So I'll look into this cooperation with those institutes.
Okay, great. Thanks. Thanks for that response. Next question here. This is kind of an interesting one. As just a little bit of a background information, GEO has recently engaged with the private sector in arranging credits to use cloud computing services. We have made arrangements with Amazon Web Services, with Google Earth Engine, with Microsoft and Azure. And so the question comes, will the GEOSS platform link the cloud services that are being offered to GEO from these commercial providers? In other words, how do we see that these particular services could be integrated into the GEOSS platform? Anybody? And I'll throw that one out to anybody who is brave enough to venture into these waters.
I will start, and then I'm sure that others will contribute. Well, I mean, this is exactly one of the components of the landscape that we presented. The big box on the left side actually was capturing all these platforms, because they are mainly platforms. Or, I mean, if you like, cloud systems. Cloud is a very generic term, because then you have a cloud that provide infrastructure services or platform services, or even software, services. And this is the main diversity between AWS, the Amazon Web Service, which is mainly providing infrastructure as some platform services, and Google Earth Engine, which is largely providing a software, service. So today, of course, I mean, this is a very important point. And in keeping with the system of systems, principles, we are studying how to, support not just one, or I mean, support means utilize, not just one of these platforms or infrastructure, but many, and keep it open, because clearly, I mean, today we had 3 or 4, but in the next year, they could be other 2 or 3 that want to, contribute. And here, the main challenge, I mean, there are several challenges. But one, technological important challenge, it is called the multi-cloud interoperability challenge. This is a real, barrier. It is presently for many private companies, because they use more than one cloud and more than one platform. For instance, Amazon and Microsoft, Amazon and Google, Amazon and IBM, etc. And I mean, today, they are not allowed to move their data and their, software easily from one platform to another platform. So clearly, this is not just a GEO, challenge. It is a more general challenge. These big companies, of course, realize that, and they are working in order to establish alliances and interoperability instruments, such as, virtual clouds, virtual middleware, etc., but still, this is not so simple. And this is exactly, why we are, also working on this, looking at what is out there and what we can do in order to keep with this system of systems, and openness and fair, principle. Another, and then I just close it, another, challenge then, of course, it is also a privacy, a privacy challenge, which is, not just for the cloud, but in any case, when you share data, you must be sure that your data policy is, supported by the systems, not just the cloud, any system that you are using. This is just to give you a glimpse of what is, what is the difficulty here, and it is not just GEO. I can, assure you, this is one of the, of the ultimate challenges when you use these big analytical systems.
Great, thank you very much, Stefano. Yeah, Joost, go ahead, please.
Yeah, maybe I can add just a bit to what, let's say, Stefano was saying. Actually, maybe from a more practical point of view. As you may know, we have adopted the last years more like a user-centric approach in, let's say, evolving the GEOSS platform. Actually, there within the GEOSS platform, we distinguish between the operational platform and what we call a development platform, where we tried and where we did some proof of concepts. And moving towards a user-centric approach, we are, let's say, in the development platform as well, providing access to information and services. And some of these services are provided on a platform which is actually provided by CNR, which is called VLAB. And via VLAB, we connect as well to different European cloud platforms, which we call the DIASs, the Copernicus ones, like Onda and Creo DIAS. We also use their Amazon Web Services. So I think that there is no real technological issue in connecting actually to clouds. It is more a matter of, let's say, agreeing as well within the GIDTT actually how to further evolve and agree on, let's say, what the architecture and the implementation actually will be. But of course, there are all kinds of other issues to be looked into as well. But from a technological point of view, yes, we could and we can connect to different clouds. And we are looking into this.
Great, thank you very much. Let's move on now. Since you mentioned GIDTT, Joost, there's a question here that is asking, what is the role of the GIDTT? So again, for those of you who aren't acronym savvy, that's the GEOSS Infrastructure Development Task Team. So what is the role of the task team to ensure that the Knowledge Hub works in unison with other geo infrastructure so that we bring out the expected game changer in terms of increased use of geo products, services, and so what are we doing to make sure that the Knowledge Hub increases uptake of that which is being offered through GEOSS? And I don't know, maybe Ivan, would you want to kick us off on that one?
I'd be happy to, Doug. Thank you for the question. It's a good question. I think we touched on this just briefly during our presentation, that the role of the GIDTT is to work with the Secretariat in implementing the implementation plan that's been developed for the Knowledge Hub. So this will be a collective team of experts that will help guide the work, working with Gilberto and his colleagues, Doug, of course, in orchestrating the work behind the Knowledge Hub. And also, as you've seen from the schematics that Stefano has presented, we see the Knowledge Hub as part of that infrastructure. So I think over the next year, we'll be doing some exploration and maybe identify a couple of use cases and determining how this would work. But we see, just in summary, that the GIDTT has a significant role working together collectively to help with the implementation of the Knowledge Hub and leveraging that important work that will be the result of that implementation.
Great, thank you. Anybody else want to weigh in on that one? Okay, then we'll move on here. Another question back to you, Joost. You mentioned a project called EDGE, where there are some results. This question is just asking where the information from that project can be found. You tell us?
connection was not that great, but I understand that the question is where information or results from the EDGE project will be made available. We are actually concluding, let's say, the writing of the final report, and this final report, including other deliverables, will be made available. And I believe that we should agree together with the GEO Secretariat maybe to put these deliverables available via as well the GEO Secretariat's website. But otherwise, I would let's say find an agreement as well with the European Commission that they will be made available as well via a website from the European Commission.
Okay, great. Thanks, Joost. All right, let's see. We have our time is ticking away here. How about this? Is a good question, and again, this is one I think I'll throw out to anybody who wants to take it. So we've spoken about the regional GEOs, regional platforms. Are those resources or something like Digital Earth Africa? Are those how are those connected to the GEOSS platform, or if not, how do we envisage that they will be? I think that's particularly pertinent for Digital Earth Africa.
Okay, I can start. Indeed, I mean, this is another of the standing challenges, but let me say opportunities, for the evolved GEOS, because clearly, as Ivan and others outline regional initiatives, and in particular the regional systems that have been developed or that have been, reach out to, they are extremely valuable in order to provide those knowledge bodies. That means data, information, models, documents that we are looking forward to connect. So this is exactly, where regional GEO stay into the architecture that we depicted, So it is the link between the global level, these, central light components that I mentioned before, and the national and regional, systems. And this is also particularly important because, as we outlined several times, we are looking for use cases in order to engage more and in order to serve better, the users. So how? Of course, we have to ask for these initiatives for their needs, so for the user scenario, and then engage those systems as the instrument in order to collect the global to the local. So this is from a conceptual, point of view. Then when you have to come up with the software implementation, of course, that largely, depends on what are those regional or national systems in terms, once more, if they provide some infrastructure or platform or software or tools, resources. So if they do that at the different levels, how they, contribute. So what is the interoperability instrument in order to be part, in order to be one of those enterprise systems contributing to the GEOS ecosystem? And of course, as Paolo said, it is likely that they will implement different instruments working at different levels and governed by different policies. This is, natural, this is physiological, and the GEOS as a system of system has to take care of this, being flexible. And this is why we need one, collaborative central components, because this must be governed.
Okay, thank you. Anybody else want to weigh in on that one?
Well, Doug, this is Ivan. I would just add that I think fundamentally we expect that the regional GEOs will be interoperable with GEOSS, and we're promoting the use of those architectural principles to ensure that occurs. We've demonstrated that in a limited way with AmerGeo to date, which is a platform that we're utilizing support the AmeriGeo activities. And we've had some pretty good use cases and also some results that really showcase how that can in fact be done. The expectation would be that the information and data flows can happen through both of those interfaces, by which the folks at the regional level can leverage the great content that's available in GEOSS, and then GEOSS also can leverage those resources available through the AmeriGeo platform as well.
Great, thank you. Well, our time has evolved here, and we are coming to the close of this session. I would just like to thank my colleagues here for your presentations and for your input. Thank you for your attentiveness, and I've just got one slide here I'll finish with to kind of draw things to a close. So again, this whole session was an introduction to GEOSS and the GEOSS Infrastructure Development Task Team and its activities. Let me find, here we go. And the activities that the GIDTT has been involved in and will continue to be involved in pertain essentially to data, to the open access and reuse of that data across the work program, and also facilitating discovery and access to that data. We're also documenting user expectations and requirements in connection with GEOSS services, functionalities, and so forth, expansion of the user base. And then finally, you have heard several presentations on thoughts for GEOSS, the GEOSS platform and architecture itself, how it can evolve into the future according to different models and different needs as we talk to the leadership of the work program activities to make sure that we meet their needs and expectations. So that brings us to the end of this session. Thank you very much for your attention. We now go on a 30-minute break. So thanks for being a part of this session, and we'll see you again in 30 minutes.